In lesson 32, we're going to simplify some more square roots, and we're also going to talk about congruent shapes, especially congruent triangles. So today we're going to be talking about square roots of fractions. And we have a quotient theorem for square roots that says if you have the square root of a fraction, you can take the square root of the numerator and put that over the square root of the denominator. It also says you can go the other way because sometimes that's helpful. If you have one square root over another square root, you could think of that as just the square root of the fraction. For example, if I had, well, the way we're going to be doing today, if I had like the square root of 9/4, I could simply think of that as the square root of 9 over the square root of 4, or 3/2, and that makes sense. 3/2 times 3/2 is 9/4. What we're particularly going to be working on today will be some kind of messy things that look like this, not quite as nice as the one that I just put up there. So we'll think of that as the square root of the numerator over the square root of the denominator. Who can tell me what I need to do to simplify that and clean it up a little bit? Amelia? And I love the way you said it, multiply by root 7 over root 7. Multiply numerator and denominator by the same thing. So we have a regular 7 in the denominator, and then we put these back together as root 21, and we can't reduce that. So that is our final answer. Now we're going to do a couple of things to make these just a little bit harder. Every time you're going to take not one of these, but two of them, and add them together. So I need to do that same process to each of these two things that I'm adding together. So I'm going to say square root of 3 over square root of 5, and I'm going to leave myself some room because I know I'm going to have to do some stuff for that. And then I'm going to write down square root of 5 over square root of 3. Daniel, what should I multiply the first one by? Square root of 5 over square root of 5, so that we get root 15 over a regular 5, and I'm still going to leave some room. And what do I need to multiply my other one by, Elias? If I multiply the second one by root 5 over root 5, is that what I need?
Or by root 3 over root 5?
Well, I need to multiply numerator and denominator by the same thing. What do I multiply by to clean up the denominator? Root 3, so I need to multiply by root 3 over 3. That's late in the day, I know. My brain's doing the same stuff. So I get root 15 over regular 3, so now I have two fractions that I'm adding. So Nicole, anytime I add fractions, what do I have to worry about? I got to get a common denominator, so what do I need for the denominator to be? We need 15 for our common denominator. That means this one I need to multiply by 3 over 3, and this one by 5 over 5. So now I have a common denominator of 15, and I have 3 root 15 plus 5 root 15. Am I finished? And Allie, why am I not finished? You were shaking your head no. So we need to put those together and get 8 root 15, because anytime the square roots are the same, we put those together the same way we would if they were 3x plus 5x. As long as it's exactly the same square root. We just add the numbers in front of them. And that can't be reduced anymore, so that one is finished. Thumbs up, thumbs down in the middle. How do you feel about these two examples? Okay, we're going to do one more that's a little bit messier still, and then we'll move on to congruent things. So this time I'm subtracting, and this time I have another number out in front. So what I'm going to do with these, I am going to still do the root 2 over the root 7. I'm going to think of this 2 out in front as a 2 over 1, helping me remember that means I just have a 2 in the numerator, so I have 2 root 2 over 7. And I'm going to leave some space. And I'm going to think of the 3 as 3 over 1, so I know it goes in the numerator. And then I've got the root 7 over root 2. Now I do the same thing. So, Ella, what do you want to do to the first one?
Multiply by root 7 and root 7.
Sounds good to me. So that will give us 2 root 14 over a regular 7 minus the second thing. Coleman, what do you want to do to the second one? If I just multiply by root 2, I've changed the number. Root 2 over root 2. So now my denominator is a regular 2, and my numerator is 3 root 14. Abby, what do I need now? Because what am I trying to get to? So we're trying to get a common denominator of 14. So multiply the first one by 2 over 2, and we have 4 root 14. What about the second one, Beck? How do I get a 14 for my other denominator, that 3 root 14 over 2? So I've got the denominator of 14 again, and now I have minus 21 root 14. Be careful, what is 4 minus 21 that we have in front of that root 14? Mateo, what's 4 minus 21? So final answer, negative 17 root 14 over 14. Everybody good with that? Okay, talking about congruent things next. Congruent simply means that we have the same shape and the same size. If we are talking about line segments, it means they're the same length. They're both 5 centimeters or 5 feet or whatever. If it's angles, it's not how long I've drawn the lines that make the angle. It's how many degrees if I measure with a protractor. If both of those are 37 degrees, they're congruent angles. It does not matter how long the segments or rays are that we draw for the sides. Triangles, which is what we'll focus on today, can be matched up so that we've got 3 sets of matching angles. And we have 3 sets of congruent sides. Pretty easy to see on here. We've got matching sides that are 14. We've got matching sides that are 10. We've got matching sides that are 12. I can also match them up so the angles are exactly the same. Maybe I have to twist them or slide them a little bit. So maybe I take this and I need to twist it around and slide it this way so that those match up. Okay, they're congruent. They're the same shape and the same size. However, if I want to get to this one on the bottom, probably going to need to do a little bit more. If I mow it down here like this, they don't quite match up. In this case, I need to turn it over and then slide it around until they match up. But again, they're the same size and the same shape. So does that make sense to everybody? Now, it makes a difference when we write these, how we write them down. So first off, we're going to look at that, and we've got the 2 things marked in green. That's one set of corresponding angles. I know that angle A is congruent to angle E. I also have 2 that are marked with 90-degree marks. So I know that angle C is congruent to angle D. And then AA implies AAA. My two blank ones have to also match up. So angle B and angle F have to also be congruent. So I know all my angles match up. So far that just says they are similar. They look congruent, but maybe BC is just a millimeter shorter than FD. And my eyes aren't good enough to tell that. So if the book then also tells me that BC and FD are congruent, that's enough that they're going to have to be congruent triangles. So a lot of times we're going to look at these and convince ourselves three sets of angles and one set of sides. It does also mean that all of the sides match up and are congruent. Corresponding sides are sides that are across from each other. We have BC marked as congruent to FD. I could also say that AB, which is across from the 90-degree angle, so it's my hypotenuse, needs to be congruent to the one that's across from the 90-degree angle here. So AB needs to be congruent to EF. Hypotenuse and hypotenuse are congruent. And that leaves, what, AC that I haven't done yet. That is across from the side that I haven't marked. And across from the side I haven't marked, I've got this side between E and D. It's the long leg, so if I say AC, I would need to write that as ED to make that match up. Congruent triangles, all three sets of angles, all three sets of sides. When we write that they are congruent, it matters how we write it. First triangle, I can pick any way I want to write it. I can say triangle ABC is congruent to, but then when I write the second triangle, I can't just write it any old way. I can't just automatically say, oh, alphabetical order, and actually DEF is not congruent to ABC. The reason is, whatever letter I wrote first here, I had to write its corresponding angle over here. And I said A was congruent to E, so if I start with A, I have to start with E. B, the next is my second letter, my next one needs to be F. And finally I wrote C, which corresponds to D. So if I start off ABC, my only choice for the second one is EFD. Once you have these written, that also tells us first two letters, those are corresponding sides, AB and EF. Last two letters, BC and FD, those are corresponding sides. First and last, AC, first and last, ED, those are corresponding sides. So you see how you have to be careful when you write those statements. Okay, let me do one example with you, and then we'll do some whiteboard work. We've got a couple of triangles up here. And X and T, and I don't know what they are. I'm hoping these are congruent triangles so then I can write down some equations with those corresponding parts. So, can anybody describe any angles in those two that would have to be corresponding angles because they have to be congruent? Does anybody look at the picture? Do you see any angles that would have to be congruent in there? Do you see any that would have any angles that would have to be congruent?
The two central angles.
Why?
Because of vertical.
Okay, everybody good with, we could say these two are congruent because they're vertical angles. Okay, can I get another set somewhere that is congruent? I'm told this and this are parallel. Will that help me get any? And we kind of described those as the angles in the middle, and we may need to describe, like top left, bottom left, and those kinds of words to come up with some sort of description of another set that might be congruent. Can we see any other sets in there of things that might be congruent? Maybe with those parallel lines helping us out. Evelyn?
So, the top right and the bottom left are alternating interiors.
So if I took the parallel line and this transversal, everybody see how those are alternate interiors? So then I know AA implies AAA, so these are also congruent. So I've got all the sets of the angles match up, so they're at least similar. Look at the sides. Do I know that I have a set of congruent sides? Look at what's labeled in there. Hayden, do you see any sides that have to be congruent, that we know are congruent, because we know how long they are? I don't know what X and P are. Is there anything in there that doesn't involve an X or a P, that I've got the same thing on one triangle as I have in the other one? Well, yeah, so I've got two sides that are just 4 and 4. So those are congruent. I need to make sure they're corresponding. This one's across from 2 blue tick marks. Is the other 4 across from 2 blue tick marks? So yes, they are. So I've gotten all 3 sets of angles and a set of corresponding sides. So now I can write down my other corresponding sides are equal. I've got 4x minus 1, and I can figure out what its corresponding side is. And I've got 4x plus 1, and I can figure out what its corresponding side needs to be. So 4x minus 1 is across from 1 green tick mark. What's across from 1 green tick mark in the other? That doesn't give me a lot to work with. I don't know either X or P in that, and I've only got one equation. Let's get the other one written down and see if that's going to help us any. So Leah, 4x plus 1 is across from 3 red tick marks. What's across from 3 red tick marks in the other triangle? And that one only has X in there, so you guys solve that real fast for X. So Emily, what's X?
1.
And so everybody good? If we subtract 4x from both sides, we have 8x. If we add 7 to both sides, we have 8. So x is 1. And then if x is 1, we can get p. It's going to be 4 minus 1. So p is 3. Thumbs up, down, in between. Where are we with understanding that one? Right.
Do you want us to write AAA and AAS for reasons?
No, but you're going to think that through. If you don't think it through, you're not going to set it up right. And on some of them, they're going to be messy enough to copy the picture and start marking like I did so you can tell what's across from congruent angles. What you just used, and you need to write this down and memorize it, you just use the fact that corresponding parts of congruent triangles are congruent. And that's an important theorem in geometry. The first thing you need to have is that the triangles are congruent. And that's why we looked at it. Do the angles match up? Do we get enough sides to match up that we know we have congruent triangles? Then to solve the other stuff, we took and said, okay, which missing parts are corresponding ones? They have to have the same measures as each other. We did it with sides. Sometimes it'll be for angles. And then we solved that by putting the equal sign in between them. This is not. Congruent parts of congruent triangles are congruent. Well, duh. If it were that way, congruent parts are congruent. You don't tell me anything there. If I already know they're congruent parts, I already know they're congruent. The first C is corresponding parts. And for reasons, you write down CPCTC. On the test, when we say what does CPCTC stand for, you need to write it down corresponding parts of congruent triangles are congruent. And I had somebody in an earlier class say that she remembered a CMAS question asking to write a paragraph to explain some reasoning. And she was wondering, well, can we use the abbreviation or write it out? And it's kind of like, I'm not sure because I don't get to grade those. So when in doubt, write out what it means. So if they ask you that on another test, you want to be able to write out what the reason is, what that abbreviation stands for. So write it down and memorize it. And then let's get a little bit of whiteboard practice with the kinds of things we've talked about